Hi, this video is part of my English speaking practice series, and I'm recording this video for speaking practice. And it is my third consecutive days, and probably sixth or seventh video. Mostly, most possibly is seventh. And I'm on the road, and I'm not very good in speaking in public, but lots of people are going and coming out by this road. I'm standing next to the road in the road light. I will talk about painting. How do we do industry painting in industries? So let me brief you. What do we do in painting? We do blasting, and then we do painting. Why do we do blasting? The purpose of blasting is to create roughness on the surface, and second reason is cleanness of surface. So do we directly do blasting, or is there any precautions? As inspector, we check our substrate before starting blasting. So what do we check? We check if there is any crack on the pipes, all the fittings and necessary welding or mechanical activities has been completed. There is no crack on the pipe, welding joint and other testing has been completed. There is no mud. If there is any surfaces, it must be rounded. So if the material has passed in all the criteria, we go for blasting. But we also check of environment. Humidity must be less than 85%, and dew point must be less than more than 3 degrees centigrade of the substrate. If this criteria meets, we start blasting. After blasting, we check if the blasting has been done according to our requirement. I mean, we check profile by replica tape or dial gauge micrometer, and then we do test of salt contamination by bracelet patch method or SCM 400, and we check dust as per ISO 8502-3, and once it passed in all criteria, we start painting. But in the painting, we check if the environment must be according to our criteria, such as environmental condition must be relative humidity less than 85%. Trade temperature must be should be between 10 degrees Celsius to 60 degrees Celsius, and dew point temperature must be 3 degrees Celsius above atmospheric or substrate temperature. Wind should not be very high, and then we do painting. What do we usually check in painting? Once the painting is start, as always, we check WFT, weight fill thickness, and then once the painting completed, we check TFT, dry film thickness, holiday test if there is any pinhole, and MEK test, methyl ethyl ketone test, that curing has been completed or not. These are the tests we perform. And also there is a pull-off test, I mean adhesion test, which is very important to check whether its painting has been done in good way or not. So why do we do painting? It is for the protection against corrosion. So what is the corrosion? Corrosion is degradation of material due to its environmental reaction with its environment. So what are the main component of the corrosion? It's anode, cathode, electrolyte, and metallic pathway. If all three four components meet together, the corrosion will occur. So if we want to stop the corrosion, we will have to remove at least one of these things. Since anode and cathode are parts of metal, what do we do is to remove either connection with electrolyte or metallic pathway. So we remove actually metallic electrolyte, and by stopping environment moisture to the surface through barrier or passivation. So how does corrosion occurs? Actually, when electron get released from metal, it carried out by electrolyte in metallic pathway, and it goes to cathode, and electrolyte split in hydrogen ion and oxide ion, and then hydrogen ion comes to anode. So corrosion basically occurs at anode, and electric circuit generated in electrochemical cell is DC in corrosion process. So our aim is to stop electrolyte. And what is CP? Cathodic protection. Cathodic protection is, since we know that corrosion occur at anode, so and it does not occur at cathode. So if we meet metal somehow cathode, then it will be protected, and thus we need another things which can be made as anode. So how do we do? There is a two method. First is doing coating with material which is more noble to less noble to our protected this material needs protection. And second method is to insert current. So in first method we apply zinc, aluminum or magnesium, which are more active corrosive to see our material which need to be protected. And when it's react with when it's come into contact with environment, it corrode himself other than material itself. I mean the substrate which we are protecting, it does not corrode, and the zinc corrodes itself. It's called sacrificial protection. When it about insert current, we use a step down transformer and insert current in DC form, and we made our protective part with as cathode. Usually we do in either submerged area or pipeline structure, whatever it is underground, which is always in moisture,